Alright, so now we're going to do kind of the opposite. We're going to be given the value of a trig function, and we're going to use the calculator to find the acute angle that produces that value. So, let's jump right into it. Alright, we want to find theta in degrees and in radians. Notice we have these restrictions on them, and this is what I was talking about, we're finding just acute angles right now. So theta is going to be between 0 and 90 degrees, or between 0 and pi halves. It could be 0 or 90, and it could be 0 or pi halves. So we're going to find the answer both in radians and degrees. All that means is changing the mode on our calculator. So then the question you're asking yourself, is burning in your mind, is, well, how do I do this, right? And that is a great question. I'm glad you asked. And I kind of hinted at this in the evaluating trig functions video. But we're going to use the inverse trig functions in order to evaluate in order to find the angle given the value. So the inverse trig functions are the buttons we see on our calculator that look like this. So this is inverse sine. Alright? And so that's what the little -1 means. And maybe you remember that from an algebra class where you talked about just inverse functions, right? And the notation for the inverse function was like f to the -1st. That's what this notation is showing us as well. It is not saying that we have an exponent of -1. It is the notation, the algebraic notation for inverse. So also, if you remember from an algebra class, when we find inverse functions, what we're really doing is we're switching the input and the output, and that's what we're doing here. And so if I have sine of theta equals 3/4, then I can say theta equals the sine inverse of 3/4. And I want to go back to the idea of function notation that I talked about the other day as well. Keep in mind that this is the sine of theta, right? That is all one function. So it's not sine times theta, so I can't just divide by sine. I have to switch where the input and the output are. And so that's what the inverse actually allows me to do. So this is what I'm going to type into my calculator. I'm going to do it twice because I'm going to get my answer in both degrees and radians, so I'm just going to have to change the mode on my calculator. So let's see what I'm in right now. I'm in degrees right now. Great, so let's just stick with degrees for right now. So I'm going to do second sine of 3/4. And we get 48.590. So I know theta is 48.590 degrees. And I'm going to change my mode. Go to radians. I'm going to type in the same exact thing. Hit enter, and I get 0.848 radians. And remember, there is no symbol for radians, so we just leave it like that. Okay, I want you to try to do the cosine one. It should be pretty straightforward. And then I also want you to try and do the cotangent one. You're going to have to think a little bit about what we did with the evaluating trig functions and how cotangent's not a button on the calculator. So how can we find cotangent inverse? Since cotangent's not a button, the cotangent inverse is definitely not a button, but there's a way we can do it. So think about it. Try and do both these problems. Pause the video. Unpause when you're ready to discuss. Alright, so hopefully you got the cosine. In degrees, theta is 53.130 degrees. In radians, it's 0.927. And all I did was I typed in my calculator cosine inverse of 3/5. And I just made sure I was in degrees for the degrees and radians for the radians. Great. Cotangent of theta is 3. It's a little more challenging though, maybe. Maybe not. Hopefully you're kind of catching on to this, but if you're struggling, that's okay. So one way to think about it, and there's a few ways to think about it, but this is one way, is doing what we did yesterday. Or, I'm sorry, not yesterday, but with evaluating the trig function in the calculator before. So cotangent of theta equals 3. Well, I remember that the relationship between tangent and cotangent is cotangent of theta is 1 over the tangent of theta. And so if cotangent of theta equals 3, then 1 over the tangent of theta has to equal 3. So now doing a little bit of algebra, I could multiply both sides of this equation by tangent of theta. So 1 has to equal 3 tangent of theta. And then divide both sides by 3. So 1/3 has to equal tangent of theta. Now, I would point out that if you understand the idea of a reciprocal, you actually could have just gone from the fact that if cotangent of theta equals 3, tangent of theta has to equal 1 over 3. Because that's what the reciprocal is, right? That's actually what this relationship is telling us. So we didn't have to do this algebra part to do that, to get there, but either way we needed to get to the fact that if cotangent of theta is 3, then tangent of theta is 1 over 3. So now this I can type into my calculator by doing tangent inverse of 1/3 equals theta in degrees. That's going to be 18.435 degrees. In radians it's 0.322. Okay. So now I want to back up a second. Why are the restrictions necessary when finding the angle? And the restrictions that I'm talking about are these restrictions. So why did we have to have those restrictions? Did we even have to have those restrictions? Am I leading you here? Am I trying to trick you here? What's going on? So I want you to take a minute and think about why were those restrictions necessary? Were they even necessary? Maybe, I don't know. But try to write something down, pause the video, and then unpause and we'll discuss your answers. Alright, so what did you guys say? Anyone? No? Come on. Alright, well, so one thing based on what we should hopefully understand at this point is we know there's an infinite amount of coterminal angles, and so every location, every coterminal angle is going to have the same trig value. So if we didn't restrict the angle, there's actually an infinite amount of answers. Now we're going to learn in a minute it's even more than just the coterminal angles, but for now we should understand that the coterminal angle, the idea of that there's an infinite amount of coterminal angles is going to lead to the fact that there are an infinite amount of possible angles for a given trig function that will give us the same value. Okay. I want you to try this next one on your own. A little bit of an application problem. Should hopefully be kind of straightforward, but maybe not. So you've got a ramp 27 feet long that rises to a loading platform that is 5 feet off the ground. I want you to draw a right triangle to represent the picture, use a trig function to write an equation involving the angle of elevation, and then solve for the angle of elevation. So pause the video, try to do that problem, unpause when you're ready to check. And if you can't get all of it, at least try to do some of it. Just draw the picture, maybe write an equation. Whatever. Try your best. I believe in you. Pause the video. Okay, so hopefully you drew a right triangle. That's a start, right? And then, so it's a ramp. So we kind of draw like this. Here's my right angle here. The ramp goes up a total of 5 feet. The ramp is 27 feet long. Here's my angle of elevation, so that's what I'm going to call theta. So I noticed then, so that's part A, right? And then I labeled that, okay, well this is the opposite and this is the hypotenuse. So if I'm going to use a trig function to write an equation involving the angle of elevation, which trig function should I use? Well, I should use the one that includes opposite and hypotenuse. That's sine. It's also cosecant, right? But since we know we're going to be typing stuff into our calculator, we might as well just write it in terms of sine. So I know sine of theta is opposite over hypotenuse, so that's 5 over 27. And then I want to solve for the angle of elevation. So theta is the sine inverse of 5 over 27. That means if I type this into my calculator, check which mode I'm in. If I'm in degrees, I should get 10.672 degrees. And if I'm in radians, I should get 0.186. Now, one thing I would point out, I didn't specify which units your answer should be in. So you could really answer whatever you want. However, a lot of times when we're dealing with application problems, you'll notice that angles are usually in degrees, because those are the angles that we are commonly used to seeing, right? Like a lot of times in the real world, we hear about things in degrees. So when we're giving an application answer, we can kind of visualize how big or small 10 degrees is, where it's a little bit more difficult for us to think about how big or small 0.186 radians is. Just something to think about.